Hi everyone, it's Sunday morning, 3 AM Sunday morning. I've been in the garage building all day. Right, yes, I'm a little bit tired, so excuse me. Right, in this video, which I think is preliminary 4, part A, I'm going to do part B tomorrow. This one will be uploaded tonight just for you guys. People, rather. Okay, what I want to talk about is pulse motor timing. Right, and as you've guessed, I'm in the kitchen. So I'm kind of on a wind down now. Probably go to bed, it's 3 AM now, just to prove it. Number 1, pitch black outside. Number 2, the clock. Right, yeah, Dougie's down there. Both of them, lazy things. Yes you are. Right. Okay. To help, we will need lots of coffee. And there's one I made earlier. Wonderful. Right. Right, okay, so what happens is, as the magnet approaches the coil, voltage drops down, and then comes back up again, and then drops down. Right, can clearly see that, good, wonderful. You'll notice that it's a sine wave. Right, okay, right, this is the basic of what we think is happening. So, this point here, right, that is a point that I call top dead centre. Right, that's actual mechanical term for piston engines, but it works the same for pulse motors. Okay, this bit, right, the standard Bedini completely ignores. Right, so normally that diode that goes from the emitter of the transistor to the base in reverse, right, normally shorts all that out via the via your pot. Now on mine, obviously, I get rid of that diode. Right, so, but anyway, we completely ignore that and look at this bit. Okay, got voltage going up. Right, now on the transistor, right, you've got a minimum voltage where the transistor begins to open, and the saturation voltage, which is the point where the transistor is fully open. Okay, so for example, on this sine wave, we'll assume the minimum voltage is about there and the saturation voltage is there. So, ruler. You've got to be kidding me. Oh well, didn't fetch a ruler up. I'll do. Placemat. Wonderful. Right, so, anything above the placemat, right, which is the minimum voltage here, right, begins to trigger the pulse. Right. Anything then above the placemat now, which is there, right, is when it's fully open. So we'll draw this all the way across, just roughly. Right, there we go. As you can see, so those two lines indicate minimum trigger voltage and the saturation voltage. That's the voltages without the pot in place. So if you just connected the trigger coil straight to the transistor. With the pot, obviously you move this lot further up. Right, so you end up shortening the time. the fun bit. Right. As you can see from this, that's top dead centre. That's at a point where the magnet is the closest to your core for the drive coil as possible. Now, as you tune the pot to make it run faster, which is the odd thing, right, you move up this scale before it triggers. So of course, right, as you're increasing the resistance of the pot, right, you're actually delaying the trigger point, right, so you end up moving through time, right. However, the trigger system that I'm creating allows me to set two different points, that is the turn on point and the turn off point. So, for example, on mine I can have a turn off point that is literally just past top dead centre, right, and a turn off point up here. Right, so instead of everyone else's lines being parallel, that is, mine is not. So I end up with, God, I can't draw straight. So I end up with points like that. Right? The system that I'm creating basically says it finds the peak point here, right, and then I can set a certain voltage past the peak to turn off. Right, so I turn on at a very low voltage and turn off just after the peak. Right, which means, if I draw it on here, right, because I'm turning on literally just after the magnet starts to leave the core, I get a more efficient pulse than if this was moved to, say, here to here. So it makes it more efficient and I get a hell of a lot more torque. Now at the moment, the line that I've drawn there is the line that I'm looking for. At the moment I think mine's about here to about here, I think it is. Right, so it's a bit flatter. The sharper that line, right, the more vertical the line is, right, the more efficient the pulse becomes. Right. Even if the time between the turn on and turn off points is the same, right, the closer the turn on point is to top dead centre, the more power you get transferred to the magnet, to the rotor, right, for the same amount of current being drawn from the battery. Ergo, it's more efficient. That's in theory anyway. Now I have had a few problems with it. It's been doing some pretty frigging weird things. Now I could do with some kind person that's got an oscilloscope, if they'd stick their oscilloscope on the trigger coil and just give me the waveform from the trigger coil. If anyone's got a dual channel oscilloscope, I could do with an overlay of when it's pulsing in relation to the voltages that are going on the trigger coil. Unfortunately I haven't got an oscilloscope and I'm encountering some weird things going on in the waveform. What I suspect is going on, if we take a quick look, I'm going to have to edit this video because it's over 11 minutes. Right, if we take a look, what I suspect is going on, draw it briefly here, right, is I think this point here is actually doing that. Is jumping up and down, which is causing me a load of problems, unfortunately. So, that's part 1 done with. I'll do part 2 tomorrow and upload it. Any questions, as always, give me a shout. Okay, cheers guys.